Engineers want to design seats in commercial aircraft so that they are wide enough to fit 90% of all males. Accommodating 100% of males would require very wide seats that would be much too expensive. Men have hip breadths that are normally distributed with a mean of 13.9 inches and a standard deviation of 0.8 inches. We want to find the 90th percentile, and that is find the hip breadth for men that separates the smallest 90% from the largest 10%. And hint, we want to be able to draw a graph. Now, 90 percentile, or P subscript 90, means that 90% of the data is less than the random variable x. That is, the area under the normal curve to the left of x is equal to 0.9000. So we're going to draw our bell curve. So we draw our bell curve. Okay, what do we know? We know the following. We know that the mean of our problem is 13.9 inches. Okay, and so we're looking for the area right now that represents 90% to the left. So that means 90% is going to be somewhere around here. So we want to shade everything that represents 90%. So this is 90% to the left. So now what we're going to do is we're going to go ahead and denote that this is 0.9000 for the area. Okay? And so what we want to do is we want to find out what is this value for x here. That's what we're looking for. But what we need to do first is find the z-score that's associated with x. In order to find the z-score, we need to look at the mean of being 0. So what we're going to do now is the following. We want to find the z-score that corresponds to the shaded area of 0.9000 to the left, and then rounding that to 2 decimal places. So we're going to go ahead and use StatCrunch. So we're going to open up StatCrunch. We're going to select Stat, go to Calculators, and scroll down to Normal. Okay. We want to make sure that we have the less than or equal to, so it's pointing to the left. And then what we're going to do is we're going to put in the area of 0.900. So 0.9000, and we're going to select Compute. And now let's take a look at the z-score that we get there. So there is the z-score. Rounded to 2 decimal places gives us 1.28. So therefore the z-score is 1.28. And as you can see here, this graph matches the graph that we had just drawn, which is it's very important to be able to draw that. So now that we have a z-score, we have a mean, and we also have a standard deviation that's given, we can now find the value of x. So we know the z-score is 1.28, and then to obtain the corresponding x value, we're going to substitute the mean to be 13.9, the z-score of 1.28, and the standard deviation of 0.8 into the following formula. So there's our following formula. Okay, we know the value of the mean is 13.9. We know the z-score is 1.28, and the standard deviation is 0.8. So now what we want to do is we want to be able to multiply them. So take 1.28 times 0.8 and add that to 13.9, and that gives us 14.9. So therefore up here, this x actually equals 14.9, which makes sense because it's to the right of 13.9. So therefore, the hip breadth that separates the bottom 90% from the top 10% is the 90th percentile, which is equal to 14.9 inches. Now the top 10% would then be this part, because that would be the 10%. area.